Good morning. My name is Naresh Pradhan, and today I'm going to teach you the first chapter of engineering mechanics, that is fundamentals of engineering mechanics. So this is the fundamental part. But before we proceed to the chapter, we must know what is in this chapter. That means what we are going to deal with in this chapter in the upcoming days. So here are the content. So we'll first of all we'll study about or we'll define the mechanics. That means we'll study about what is mechanics or what is engineering mechanics. Why we are going to study about the engineering mechanics? That is the prime thing. Then we'll classify the engineering mechanics into static and dynamic, and then we'll study about the rigid body. Now after the fundamental parts, we'll going through the force or the force system. That means here we are going to deal with, we'll define force, then we classify it, then we'll know the characteristics of force, effect of force, and the most important thing, that is principle of transmissibility and the principle of superposition, and then we'll deal with free body diagram. Then after that we'll resolute the force, then we'll compose the force, then we'll represent everything in a graphical method. And after studying about all the force system, we'll go into the moment of force. Here also we'll going to deal with, we'll define first we'll define it, then we'll study its unit, then we'll classify it, and the very important, the law of moments, then Varignon's theorem, then in finally we'll study about the couple, we'll define its unit and the properties of couple. So these are the things we are going to deal with in the upcoming days. So let's start the fundamentals, that is what is mechanics. So here is so engineering mechanics. Engineering mechanics is the branch of science. Engineering mechanics is the branch of science. That means in science there are many branches, and mechanics is one of that. And what it is telling about, it deals with the study of forces and its effect on the body. That means we are going to apply some forces to a body. Then after applied the forces, that body may be changes, that body may be displaced, that with some in velocity, with some acceleration. That's the effect. Then we'll after applying the forces, we'll study how the body behaves, how the body move from one position to another position, at what velocity, at what accelerations we are going to deal with that. So basically we'll study the state of rigid body under the action of some external forces. That means if there is a body, let's say this is the body, I have to apply some external forces. Then after applying the external forces, the body may be moved from one position to another position. Let's say the body from moved from position A to position B. That means the body transfer this distance. That means we can say the body displaced from position A to B. This is one of the effect. And if the body moves from A to B, the body must be move from position A to B with some velocity. Let's say in velocity v, it displaces from position A to B. And if there is some velocity, that means at least the body must be moved with some acceleration. So these are the effect. Basically, these are the effect we'll study about. But the thing is, the body, the body is positioned at what state? There is two state actually. First of all, the body may be is at rest, or the body may be is in motion. That means whenever we applied some forces to a body, then what is the position of the body? The body may be in rest position, or the body may be in motion position. Then I have to apply some external forces. Then what is rigid body? What is the concept of rigid body? Rigid body means rigid body means if the deformation if the deformation of a body is zero, if the deformation of a body is zero, then we call that body a rigid body. If the deformation of a body is zero, then we call that body a rigid body. So what does the mean? What is the meaning of the word deformation? Deformation means nothing, but the meaning is change in size and shape. Deformation means change in size and shape. That means let me conclude. If I applied some external forces to a body, what kind of body? The body whose deformation is zero. That means in whole mechanics, we are going to study about rigid body. That means a body whose deformation is zero. That means if I applied some external forces to that body, if that body does not show any change in size or shape, the body may be moved. The body may be moved from one position to another position, but then the change in size and shape of that body is zero, or we can simply say the deformation of the body is zero, then we can call that body a rigid body. And in the whole engineering mechanics, we are going to deal with the rigid body. And the rigid body is at what position? The rigid body may be in a rest position, or the rigid body may be in motion position. Then I have to apply some forces. Then the body may move from one position to another position with some displacement, with some distance, with some velocity, with some acceleration. We just study about everything. That are the effects of the body. So if I conclude the mechanics, so basically mechanics is nothing. Mechanics is the study of forces, but there are many types of forces. There are collinear forces, coplanar forces. We'll study about that. But so we have to apply some forces to a body. What body? Rigid body. Then the body will show some effect. Then we will study about that effect of the body. This is purely mechanics. I hope everything is clear. Then let me classify the engineering mechanics. So basically engineering mechanics is two types: static position or static dynamic. Static and dynamic. That means, as I said, we'll study about the study of forces and its effect on the body. Study of forces and its effect on the body. So in the first position, in static, the body is in rest, but in dynamics, the body is already in motion. That means in static, the body is at rest. Then the body is at, let's say this is the body. Let's say this is the body. What kind of body is this? This is the rigid body. Then I have to apply some forces, external forces. The body is in, and the body is in rest position. If I applied some external forces, then this type of system is called static mechanics. But if the body is already in motion, let's say this is another rigid body. This is another rigid body, but the body is already in motion. Then in the motion position, if I applied some forces, then this type of system is called dynamics. That means in static position, let me tell you, in static position, the body is in at rest position, then I have to apply some external position, external force, then the body will show some effect. We'll study about those effects, that is static. And in dynamic position, the body is already in motion position, then I will apply some forces, then the body will show some, again the body will show some effect, then I have to study those effects, that is dynamics. But dynamics is again two types: kinetics and kinematics. So as I said, in dynamics, the body is in motion, and if the body is in motion, there must be some forces applied. Why the body is in motion? If something is in moved, that means there must be some external forces applied. But kinetics is saying what is the amount or what is the magnitude of the forces. Please tell me. Kinetics is telling, just let me know. Kinetics is telling, let me know what is the magnitude of forces you have applied to that body so that the body is in motion position. But kinematics does not interested in how much force you have applied to that body to show, to see that effect. See, if the body is in motion, there must be some effect. Kinetics is also see the effect. Kinematics is also see the effect. But kinematics is saying what is the magnitude you have applied to that body so that the body is in motion and the body is showing some effect. But kinematics is not interested in forces. Kinematics is simply saying, please tell me the effect of the forces. I am not interested how much force you have applied to that body so that the body is in motion, then the body will show some effect. No, I am not interested in the how much force you have applied. I am only interested. I am means the kinematics. Kinematics is only interested how much or what is the effect of the forces, not how much force you have applied. But kinetics is interested in everything. Kinetics is saying how much force you have applied to the system. Please tell me. Then after the force applied, the body must be showing some effect. Then kinetics is saying what are the effect of the forces. Please tell me. That means in kinetics we consider the how much force I have applied, but in kinematics I'm not interested in how much force I have applied. Clear? I hope you are clear. Then the most important thing, as I saying, as we are going to study about the study of forces, I have saying many times the forces. Then what is force? You must know what is force. So force is an agent. Force is an agent, and what this agent is doing, it may be produce or or tends to produce. It may be produce or tends to produce. Then it may be destroy or tends to destroy. What is produce? What would it will be destroy? It will destroy or it will produce the state of the body. State means rest or motion. As I write here, which is either at rest or is it motion. So basically, force is an agent. Force is an agent which can produce or tends to produce, which can destroy or tends to destroy. What it will produce, what will it destroy, the state of the body. That means if a body, let me show you what kind of body is this. As I have said earlier, we are going to deal with in mechanics only rigid body. So let's see. So let's say this is a rigid body, and the rigid body maybe it says either or. That means either the body is in rest or in motion position. Either the body is in rest or motion positions. So I have to, if what is force, if I have applied some forces, if it is produces, if it produces or tends to produce, tends means it is capable of doing. That means that it may be move the body. Let's say this is the rest body, this body is in rest condition. So if I have applied some forces, it may be change the condition of the body from rest to motion, or it may not be, but it is capable of. If it is capable of changing the position from rest to motion, or it is changing the bo- position from rest to motion, then we can say yes, there is some forces applied. And again, if the body is in motion, if the body is in motion condition, let's say the body is motion from left to right, we have to destroy. Destroy means we have to stop. If the body is in motion, we have to stop the motion from motion to rest. How? How can I stop the motion? By applying some forces. That means if I can stop the body, or I'm capable of, I'm interested to stop the body, then we can say I have applied some forces. I have applied some forces. That means force is an external agent. What does it do? It is capable of changing a body's state of rest or in motion. That means if a body is in rest and I have applied some forces, it maybe that is always, it maybe changes the position of the body from rest to motion, or it is maybe interested. If it is interested, or if it is capable of doing the position from changes from rest to motion, then also we can say yes, we have applied some forces. We have applied some forces. So now let me tell you the unit of force. See, first of all, force, we know force equal to mass into acceleration. Mass into acceleration. That means we can write F equal to m into a. Then what is the unit of mass? The unit of mass is kg. What is the unit of acceleration? The unit of acceleration is meter per second square. That means we can say the unit of force is kg into meter per second square. But see, repeatedly saying kg into meter per second square, kg into meter per second square, it's little laborious for us. If that means I have to tell 10 kg into meter per second square, 5 kg into meter per second square. So instead of saying this kg into meter per second square, we'll name this as Newton. Newton. That means or it will symbolize as capital N. That means we can say the unit of force is kg meter per second square, right? But if someone said no, the unit of force is Newton, that means this is the same thing. Newton means kg into meter per second square. And what is this unit? This unit is SI unit. Very important. This unit is SI unit, because we have represent the force into kg, meter and second square. If I have show the force into gram, centimeter and second square, then this will convert it into CGS unit. Let me convert. So 1 Newton. So Newton means 1 kg into meter per second square. So 1 kg is. So I have to convert. I am converting this SI unit Newton into CGS unit. CGS unit means in gram, centimeter and second square. So 1 kg, how much gram? 1 kg is 1000 gram. 1 meter is how much centimeter? 1 meter is 100 centimeter divided by second square. That means 10 to the power 3 gram into 10 to the power 2 centimeter divided by second square. 10 to the power 3 into 10 to the power 2 equal to 10 to the power 5. How I get this? See, you must know a to the power m into a to the power n equal to a to the power m plus n. So by this formula, I will conclude that 10 to the power 3 into 10 to the power 2 equal to 10 to the power 5. So gram into centimeter per second square. Again, the same problem, the same laborious problem. That is, instead of saying gram centimeter per second square, gram centimeter per second square repeatedly, we have named the gram into centimeter per second square into, so 10 to power 10 to power 5 dyne. Dyne means the gram, instead of saying gram centimeter per second square in CGS unit, you can say this is dyne. That means in SI unit, in SI unit, the unit of force is Newton, and in CGS unit, the unit of force is dyne. And as I have converted 1 Newton from 1 Newton to 10 to the power 5 dyne, so we can say 1 Newton equal to 10 to the power 5 dyne. This is very, very important. 1 Newton equal to 10 to the power 5 dyne. Understood? I hope everything is clear. So, as we have studied about the force and its unit, now it's time to study about the characteristics of the forces. See, there are basically four characteristics of forces. There are four characteristic forces. First, the magnitude. Second, the direction. Third, the nature. And the fourth one is line of action. And the fourth one is line of action. What does mean by magnitude? Magnitude means what amount, or what amount you have applied the forces. Is it 1 Newton? Is it 5 Newton? Is it 100 Newton? Is it 1000 Newton? It can be anything. It can be anything. I can apply any amount of forces. That means magnitude represents the amount of forces you have applied to the body to change the position of the body from rest to motion, or from motion to rest. Simply, it means magnitude means how much amount you have applied to that body. Clear? Then the second thing is direction. Direction may be again three types. It may be horizontal, it may be vertical, it may be inclined. Horizontal means, let's say this is the body. Let's say this is the body. What kind of body is this? This body is rigid body, because again in mechanics I am going to deal with only rigid body, not the real body. So this is the x-axis and this is the y-axis. If I have applied the force, parallel to the x-axis, if I have applied the force parallel to the x-axis, then this force is called, or this force is applied in horizontal direction. That means if the force is applied parallel to the x-axis, then we can say that force is have applied in the horizontal direction. But if the force is applied like this, that means if the force is parallel to the y-axis, then we can say that force is have applied in y direction, or we can say that force is vertical force. That means this force is horizontal force. This force is horizontal force, and this force is vertical force. This force is vertical force. But if I will apply a force neither in horizontal nor in vertical, neither in horizontal nor in vertical. Let me show you. Neither in horizontal nor in vertical means if I have applied a force let's say like this. Let's say like this, I have applied a force. That means this force is neither parallel to the horizontal nor parallel to the vertical. So this direction is known as, or this force, we can say this force is inclined force. This force is inclined force. That means we can apply the force either in horizontal direction, either in vertical direction, or in inclined direction. So basically there are three directions of the forces. Then the third one. Third one is the nature of forces. What are the nature? Nature, basically there are two natures. First, the push nature, and the second is pull nature. That means, what does it say? Let's say if this is the body, again, if this is the body, this is the what kind of body? If this is the rigid body, if I have applied the force here, if I have applied the force here, that means it will move the body in this directions. Then we can say this is the pull force. This is the pull force. But if I will not apply the force here, I will apply the force here. I will apply the force here. Then we can say this force is known as push force. Push force. Here, so the nature may be push or the nature may be pull. And the last and the important one, that is line of action. What does it say? See, if I have applied, see in the rigid body, if I have applied the force here, then the line of action is, so this is the line of action. So this is the line of action. And if I have applied the force here, then what is the line of action? The line of action of the body will be this. That means this is also the line of action. If I have applied the body here, if I have applied the force here, that is parallel to the y-axis, then the line of action will be like this. So you can say this line of action, this is also the line of action. That means after applying the force, at what direction, at what direction the body will going to move, that represents the line of action. So basically we have studied about four characteristics of forces. First, the magnitude of the forces. Second, the direction of the forces. Third, the nature of the forces. And the fourth one is line of action. Now we'll study about the effect of the forces. As I've said, we are going to study about the effect of the forces. What effect the force does after applied the body. See, so again there are four effects of the body. That means what after applying the forces, what effect show the body? What will the effect show the body? We'll study. See, so what force can do? Force can make a body. Force can make a body that is at rest to move. That means if there is a body is at rest, what kind of body? Rigid body. If a body is at rest, then after applying the force, I can move. I'm not saying I have to apply, I have to change the body. But I can change the body from rest to move. That means if this body is at rest, and after applying sufficient amount of force, I can change the position of the body from rest to position, rest to motion, rest to move. So this is the first effect of the body. Again, It can stop a moving body. It can stop a moving body or slow it down. That means if a body is already in motion, let's say this body is already in motion, that means, and if I, after sometimes the body must be here, then if I will apply some forces here, then I can stop the body is moving in this direction, and if I will apply the forces in the opposite direction, then I can stop the body from moving. Or if I will apply less amount of force, then the body will slow it down automatically. Clear? Then third, it can accelerate the speed of a moving body. It can accelerate means to increase the speed. That means if a body is already in motion, let's say this body is already in motion in the clockwise direction, and I will apply the force in the same direction. If I will apply the force in the same direction as the body is moving, then I can accelerate the speed of the body. That means the body is already in right direction or in clockwise direction. I will apply if I will apply the force in the same direction, then the body will the body's speed will increase again. And the last one thing, it can also change the direction. Of a moving body. That means if I will apply the body, let's say this body is motion in this direction, and after sometimes the body must be here, and if I will apply much much greater force than the body is moving from left to right, if I will apply a greater force, if I will apply a greater force, then I can also change the direction of the moving body from here to here. That means from clockwise to anti-clockwise, from right direction to left direction also I can change. How I can change? By applying some forces. That means there are four effects. First, it can make a body from rest to move. Then the second, it can slow it down or it can stop. Then third, it can accelerate. And the fourth one, it can change the direction completely from one direction to another direction. So these are the effects of the forces. Thank you.